Hello and welcome to this exploration of one of the most fascinating periods in Earth's history, the Cambrian explosion. This event, which occurred around 538 million years ago, marks a pivotal moment in the evolution of life on our planet. It's a period that has captivated scientists for centuries and continues to be a source of intense research and debate. Today, we'll delve into the intricacies of this remarkable time, examining the evidence, theories, and implications of this evolutionary burst. Now, you might be wondering why this period is called an explosion. Well, it's not because things were literally blowing up. Rather, it refers to the sudden appearance of a wide variety of complex animal forms in the fossil record. Prior to this, life on Earth was relatively simple, composed mainly of single-celled organisms and small multicellular creatures. But during the Cambrian explosion, we see a rapid diversification of life forms, with the emergence of most of the major animal groups we recognize today. It's as if life suddenly decided to get creative, experimenting with a multitude of new body plans and lifestyles. The Cambrian explosion can be viewed as two waves of metazoan expansion into empty niches. First, a coevolutionary rise in diversity as animals explored niches on the Ediacaran seafloor, followed by a second expansion in the early Cambrian as they became established in the water column. To understand the Cambrian explosion, we must turn to the fossil record. This is where things get truly exciting for a paleontologist like myself. The Cambrian period has gifted us with some extraordinary fossil deposits known as Lagerstätten, which preserve not just the hard parts of organisms, but also their soft tissues. These rare windows into ancient life have been crucial in piecing together the story of the Cambrian explosion. One of the most famous of these Lagerstätten is the Burgess Shale in British Columbia, Canada. Discovered in 1909 by Charles Doolittle Walcott, this site has yielded a treasure trove of exquisitely preserved Cambrian fossils. The organisms found here are often bizarre and unfamiliar, challenging our understanding of early animal evolution. Take for instance the five-eyed Opabinia or the spiny slug-like Wiwaxia. These creatures were so unlike anything known that early researchers assumed they must represent entirely different phyla, unrelated to modern animals. Opabinia made the largest single contribution to modern interest in the Cambrian explosion. But it's not just the Burgess Shale that's important. Other key sites include the Chengjiang fossils in China and the Sirius Posset in Greenland. These locations have provided us with a wealth of information about early Cambrian life, allowing us to piece together the evolutionary relationships between these ancient creatures and modern animals. What's particularly fascinating is how these fossils reveal the emergence of key animal features, things like eyes, mouths, and guts, that we now take for granted. Now, one of the most contentious aspects of the Cambrian explosion is just how explosive it really was. When I first started studying paleontology, the prevailing view was that the Cambrian explosion represented a genuinely rapid burst of evolution, with most major animal groups appearing within a span of just 10 to 25 million years. This idea was championed by paleontologists like Stephen Jay Gould, who saw it as evidence for a pattern of evolution characterized by long periods of stasis punctuated by rapid change. However, more recent research has begun to challenge this view. We've discovered evidence of animal life predating the Cambrian, particularly in the Ediacaran period. Fossils like Kimberella, which lived around 550 million years ago, show signs of being related to modern mollusks. This suggests that the split between major animal groups may have occurred much earlier than previously thought. Some researchers now argue that the Cambrian explosion was less of a sudden burst and more of a gradual unfolding of evolutionary potential. To the question why we do not find rich fossiliferous deposits belonging to these assumed earliest periods prior to the Cambrian system, I can give no satisfactory answer. This debate highlights a crucial point about the nature of the fossil record. We must always remember that absence of evidence is not evidence of absence. The apparent suddenness of the Cambrian explosion could be partly due to the incompleteness of the fossil record. Soft-bodied organisms, which likely made up the majority of the early animal life, are rarely preserved. It's possible that there was a long period of evolution that we simply can't see in the fossils. This is why the discovery of exceptional preservation sites like the Burgess Shale is so important. They give us glimpses of the soft-bodied fauna that would otherwise be lost to time. Perhaps the most intriguing question about the Cambrian explosion is what caused it. This is a topic that's fascinated me throughout my career, and I've seen numerous theories proposed and debated. One of the most prominent explanations involves changes in the Earth's environment. Some researchers suggest that a rise in oxygen levels in the atmosphere and oceans could have provided the conditions necessary for more complex, energy-demanding life forms to evolve. Another intriguing hypothesis relates to changes in the Earth's geology. Some scientists have proposed that increased volcanic activity at mid-ocean ridges led to a surge in calcium concentrations in the oceans. This could have made it easier for organisms to build hard shells and skeletons, potentially explaining the sudden appearance of mineralized fossils in the Cambrian. It's a compelling idea, but like many aspects of the Cambrian explosion, it's still hotly debated. Newer research suggests that volcanically active mid-ocean ridges caused a massive and sudden surge of the calcium concentration in the oceans, making it possible for marine organisms to build skeletons and hard body parts. Ecological factors have also been proposed as drivers of the Cambrian explosion. The evolution of predation, for instance, could have sparked an evolutionary arms race, leading to the rapid development of new body plans and defensive structures. This idea of coevolution, where different groups of organisms evolve in response to each other, is particularly appealing as it could explain both the increase in diversity and the apparent speed of the changes. However, it's worth noting that evidence of predation exists in earlier periods, so this alone can't explain the timing of the Cambrian explosion. As we wrap up our exploration of the Cambrian explosion, it's important to consider its broader implications. This event wasn't just a fascinating episode in Earth's history, it fundamentally shaped the course of life on our planet. The body plans and ecological relationships that emerged during this period laid the groundwork for all subsequent animal evolution. In a very real sense, we can trace the roots of modern biodiversity back to this creative burst over 500 million years ago. One of the most profound insights to come from studying the Cambrian explosion is the role of contingency in evolution. The particular forms that emerged during this period were not inevitable. They were the result of a complex interplay of environmental conditions, genetic potential, and chance events. Had things played out differently, the history of life on Earth could have taken a radically different path. This underscores the precariousness and preciousness of life as we know it. Replay the tape of life, and the outcome will be different each time. As we continue to study the Cambrian explosion, new discoveries and analytical techniques are constantly refining our understanding. Recent work, for instance, has suggested that the explosion may have been less abrupt than previously thought, with evolutionary innovations accumulating over a longer period. This doesn't diminish the importance of the Cambrian period, but it does highlight the complexity of evolutionary processes and the need for nuanced interpretations of the fossil record. As a paleontologist, I find this ongoing process of discovery and reinterpretation incredibly exciting. The Cambrian explosion remains a vibrant area of research, continually offering new insights into the history and mechanisms of evolution. As we conclude our journey through the Cambrian explosion, I'm struck by how this ancient event continues to resonate with our modern world. The rapid diversification of life during this period offers intriguing parallels to the accelerating pace of technological and cultural change in our own time. Just as the Cambrian saw the emergence of new body plans and ecological relationships, we're witnessing the birth of new technologies and social structures that are reshaping our world at a dizzying pace. Moreover, the study of the Cambrian explosion underscores the profound interconnectedness of life and environment. The evolutionary innovations of this period were likely driven by, and in turn influenced, changes in the Earth's geology and chemistry. This serves as a powerful reminder of the delicate balance that sustains biodiversity, a lesson that's particularly relevant as we grapple with the challenges of climate change and habitat loss in the present day. The Cambrian explosion highlights the importance of understanding deep time and the interconnectedness of life and Earth systems for addressing current and future environmental challenges. Finally, the ongoing debates and discoveries surrounding the Cambrian explosion remind us of the dynamic nature of scientific knowledge. Our understanding of this pivotal moment in Earth's history continues to evolve as new evidence comes to light and new analytical techniques are developed. This serves as a beautiful illustration of the scientific process in action, showing how our knowledge is constantly refined and expanded through observation, hypothesis testing, and spirited debate. As we face the complex challenges of the 21st century, this spirit of inquiry and openness to new ideas will be more important than ever. Thank you for joining me on this exploration of the Cambrian explosion. I hope it sparked your curiosity about the history of life on Earth and the ongoing process of scientific discovery. If you've enjoyed this video, please consider liking, subscribing, and sharing your thoughts in the comments. Your engagement truly helps support the channel and shape future content. Until next time, keep exploring the wonders of our planet's past and present.